Good morning. I am D. Sengotin, Assistant Professor of Physics, SNS College Technology, Coimbatore. Today we are going to study about magnetic materials. So basic terms and definition of magnetism. So first we are going to study about magnetic dipoles, a system consisting of two equal and opposite poles separating a small distance, that is magnetic dipoles. Then the dipole moment or magnetic moment associated with the magnetic dipole or a magnet, it is the product of force strength and length of the magnet, that is capital M equal to M into L. So small m equal to magnetic force strength and L equal to length of the magnet. Then the magnetic field, when a material placed in a magnetic field, the space around the magnet or the current carrying conductor where the magnetic effect is felt, that is called magnetic field. Then the next important line is magnetic force, then magnetic lines of force. So magnetic field is assumed to consist of lines of magnetic forces, which is defined as continuous curve in the magnetic field. So the diagram shows that the north pole and south pole, the lines of force passing towards south pole. So the amount of energy, the amount of magnetic forces depends upon the applied field. So magnetic flux, total number of magnetic flux, total number of magnetic lines, bunch of lines or group of magnetic lines of forces are called magnetic flux. So the next is magnetic induction or magnetic flux density B, the number of lines of force, magnetic force passing through the unit area of cross section A. Then magnetization, intensity of magnetization, it is the process of converting non-magnet to magnetic material. So the symbol used by intensity of magnetization I. So I equal to magnetic fold strength and the magnetic fold strength or magnetic moment per unit volume. So first of all, we know about the magnetic field, the magnetic lines and the magnetic lines of force. Then now magnetization, then intensity of magnetization. Then the next important question is magnetic susceptibility, high M. The susceptibility is a ratio between intensity of magnetism I and magnetic field intensity. So we already know that I equal to the process of converting non-magnet to magnetism, magnetic material. The magnetic field intensity is called the amount of force experienced by the magnetic material, that is ratio between I by H equal to magnetic susceptibility. The diagram shows that the first diagram, the material placed in the magnetic field, lines of force expelled from the material. The second diagram shows that the lines of force passing through the material. So it totally depends upon the amount of force passed, then amount of force experienced by the material. So depends upon the nature of the material. If we placed diamagnet, the lines of force did not pass through the material, then the material placed in the magnetic field, all the lines of force passing away from the material, that is called non-magnet, not having permanent magnetic moment. Then the second diagram shows that the lines of force passing through the material, that is paramagnetism or ferromagnetism. So in case I by H, high M value is positive, that is magnet, that is I by H equal to negative, is called non-magnet or diamagnetism. The next is magnetic permeability, ratio between magnetic induction and magnetic field intensity, that is mu equal to P by H. So the magnetic susceptibility is I by H, permeability mu equal to P by H. So P equal to magnetic flux density, so B equal to total number of lines passing through per unit area. So divided by H equal to the amount of force experienced, that is called magnetic field intensity. So finally mu equal to ratio between P by H. Okay, so in magnetism, the first line about magnetism, magnetic field, then magnetic lines of force, magnetic flux density, field intensity, then intensity of magnetization, then finally classification of magnetism or magnetic materials. So basically we are having two different types of magnetic materials, that is first one is not having permanent magnetic moment, the second one is having permanent magnetic moment. Then the example for not having permanent magnetic moment, that is diamagnetism. Then having permanent magnetic moment, that is example, first one is paramagnetism, the second one is ferromagnetism. And also the two different types